Alright, this is your 8-5 video. This is the last lesson for chapter 8. So far when we've been doing trig, we've been limited to right triangles because that's all the basic trig works for. Today we're going to figure out how to kind of work around that rule and two things that we can do if we don't have a right triangle, we can still use trig. Okay, so the first thing we're going to do is just regular tappy-tappy with angles that are greater than 90 because we haven't seen that yet. So we can do the still make sure we're in degrees. We can do the tangent of 103 and I get negative 4.33. So with regular acute angles, tangent had to be positive, but now we see here it is negative. Cosine of 165 is negative 0.96, actually that would be 97. Again, with regular acute angles, cosine had to be positive between 0 and 1, and now we see here it is negative. And sine of 93 is, well, it's 0.998, so I guess that would round to 1, but it's not exactly 1. Sine of 90 is exactly 1. So we can see it's close, but it's not exactly. Okay. So one of the ways that we can get around having to use a right triangle, if the triangle's not a right triangle, we can use what's called the law of sines. So obviously it's going to use sine. And this is the law of sines. It says the sine of A over A. So his angle over the side that it's across from is equal to the sine of B over the side B is equal to the sine of C over the side C. Now, you're only going to use two of these at one time. So if I'm talking about A and B, I can use two of these, set up a proportion, and cross multiply for the one I don't know. Or if I have B and C, I can set up a proportion with B and C. So you're never going to have all three of them at the same time. Now, here's what's going to be super important today is that you know when to use which law, because we're going to learn two laws. So we're going to use the law of sines if we have two angles and a side. So that would be angle side angle or angle angle side. We can also use it if we have two sides and an angle, but the angle is not the included one. So notice, this isn't side angle side. That's not what this is. This is side side angle. So you need to memorize these because you'll need to know when can I use the law of sines. Okay, so here we go. Let's look at this one. We are looking for FG, so I'm going to call that X. What I'm given here is I'm given angle angle side. So I know that's going to be law of sine. So I'm going to be setting up a proportion. So I always start with the side and the angle that I know that are related to each other. So I know the sine of 39 over his side is 40 is equal to the sine of 32. And his side is the one that I don't know, so that's where I'm going to put the X. So here you can see this is just a regular proportion. Sine is on top, and the side lengths that they're across from is on the bottom. So sine of 39 over 40, sine of 32 over X. Then this looks a lot kind of complicated, but it's really just a proportion that you're going to solve like we did in chapter 7. So when I cross multiply here, I get X times the sine of 39 is equal to 40 times the sine of 32. To get X by itself, I would have to divide by the sine of 39. And over here to keep it even. Now you're just going to type all this in your calculator, and I type it in two separate pieces. I do the numerator first, 40 times the sine of 32, and then you can hit enter. Then from here, right away, without typing anything else, I can just hit divide by the sine of 39, and you can see that your calculator brings up this ANS right here, and that stands for answer. So it's actually taking all of these decimals with it, whereas if you had typed this in just 21.1, even that would round up to 2 divided by the sine of 39, you could see that you would get a slightly different answer. You would get 33.69, where I'm going to get 33.68. So it's pretty close, but mine is just a little more accurate. So if we can keep from rounding until the very last step. If we can hold on to all the decimals possible, we're going to get an exact answer better than a rounded answer. Okay, so let's flip and try another one. Oh, shoot. Okay, so here we're after the measure of angle Q. So he is going to go with the side 6, and 51 is going to go with 8. So I'm going to use that to set up my proportion. So the sine of 51 over 8 equals the sine of Q over 6. Okay, so still just a proportion. The two sides you know, or the angle on the side that you know, equals the part that you don't know. Okay, so I'm going to cross multiply. 6 times the sine of 51 equals 8 times the sine of Q. Now this time, since we're after an angle, from here it's just going to be a little bit different solving than it was the last time. I'm going to divide by 8 to try to isolate the variable. Then I'm going to type this in my calculator. 6 times the sine of 51 divided by 8. And I get that all this is 0.5828, blah, 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 blah. I'm going to hold on to all that decimal. Equals the sine of angle Q. Now you know from 8.3, if your answer is an angle measure, you have to do inverse. So what I'm going to do is I'm going to type sine inverse of 0.582, blah, 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 into my calculator. And again, today I'm trying to hold on to all of my decimals so I don't have to round before I round. So I'm going to type that in my calculator like this. Sine inverse. Now I don't know if you know how to do this or not, but you can go up and scroll up and choose anything that you've already done previous. So I am going to, after I hit sine inverse, I'm just going to press the arrow up button one time to highlight that 0.582 blah 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 and press enter. And then your calculator copies, it's not all the decimals, but it's at least 10 of them. And so that's way easier than you retyping them all or you rounding. So then I can type that in. So my answer is the measure of angle Q is 36 degrees. Okay, and that seems like a reasonable answer to me, because if 51 goes with 8, then the angle that goes with 6 should be slightly smaller than 51. So I know that that is good right there. Okay, pause here and try C by yourself. Okay, so on this one, we're after a side length. So I did sine of 39 over 22 is equal to sine of 88 over NP. You could either call it NP or you could call it X, it doesn't matter. Cross multiply NP times the sine of 39 equals 22 times the sine of 88. Divide by sine of 39, and you can type that all in your calculator at once, and you get NP is equal to 34.94. Okay, so law of sines doesn't work all the time. I told you there's only 3 things that it works for. It can't be used to solve every triangle. It can only be used if you know 2 side lengths and the included angle. It doesn't work. If you know all 3 side lengths, it doesn't work. Like, it only works for angle side. So instead of law of sines, now we're going to do the other one, which is law of cosines. So this is your formula for law of cosines. A squared equals b squared plus c squared minus 2bc on the cosine of A. So you can tell that law of cosines is actually derived from Pythagorean theorem. If you cover up this nonsense right here, you see that this is just Pythagorean theorem. And you know that Pythagorean theorem only works with right triangles. So basically this little minus 2bc cosine of A, this is to adjust your answer for triangles that are not right triangles. But you know how to do Pythagorean theorem, so this is just a little bit of a twist on Pythagorean theorem. Okay, when to use the law of cosines is if you have side, angle, side. So 2 sides in the included angle, or if you have all 3 sides, side, side, side. You can use law of cosines. Now, one thing to note, the reason I didn't write down all three of those formulas that are on your formula chart is because basically they all say the same thing. As long as you remember that the side that is over on the left by itself is the angle that you either know or want. So B and C, it doesn't matter where I put B and C. All that matters is that I put A over here and A over here. So whatever angle you have or you're after, and whatever side corresponds with that. And as we do a couple examples, you'll see what I mean. Okay, so this one I have side angle side, so I know that that's going to be a law of cosines. Now before I get started with law of cosines, the most important thing is to determine which angle you have and which side is he corresponding to. So I have angle 110, and the side that he belongs with is side XZ, which happens to be who I'm solving for. So what we were just talking about is if I'm going to use the cosine of 110 right here, I have to put his corresponding side over on the left by himself. So that's what I'm going to do first, is I'm going to put XZ squared over here. Now, as for who's B and who's C out of 30 and 35, no one cares. It doesn't matter which one you put. So you just put 35 squared plus 30 squared minus 2 times 35 times 30 times the cosine of 110. Okay, now all of this looks like a lot and looks scary, but really you're just going to type that exactly into your calculator all at one time. So as long as you type carefully, this isn't much math at all. 35 squared plus 30 squared minus 2 times 35 times 30 times the cosine of 110. Okay, so what we have right now is XZ squared is equal to 2843.24 blah blah blah. Now we're going to use the same trick that we just used on the law of sines, where I don't want to get rid of all those decimals. I want my calculator to hold on to them. So I still have XZ squared, and you know that to get rid of the squared, I'm just going to square root both sides. So I'm just going to hit the square root button, and then I'm going to arrow up in order to highlight that 243. Press enter to bring it all down, and then enter again. So that means XZ is equal to 53.32. And there's your final answer right there. Okay? All right, let's try another one together. Okay, so this time we're after an angle measure, which is a little bit more work, but the setup is still the same. So I'm going to be after angle T. That's important to know which angle you want, because you need to know which side belongs over on the left by himself. So in this case, I'm going to put the 7 squared over here by itself because he's the one that belongs with angle T. Then it doesn't matter where I put 11 and 13. So 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of angle T. Okay, so why this is a little more difficult is because your variable is mixed in with all this stuff. Before, your variable was over here on the left by itself, so you could just tappy. I can't do that here. I've got all this stuff in the way, so I'm going to do it in 3 pieces. I'm going to do this first, then I'm going to do the 2, 13, 11, and then I will do the inverse to get rid of the cosine. So 3 steps. So 13 squared plus 11 squared is 290. So what I'm going to do is subtract 290 from both sides to get that out of the way. So I have 7 squared minus 290. And right now I have negative 241. And this is always going to be negative. If it's not, you probably did something wrong. Equals, now I'm going to simplify this part right here. 2 times 13 times 11 equals negative 286 on the cosine of t. So second, I need to get rid of this negative 286. So I'm going to divide by negative 286. divided by negative 286. Negative 241 divided by negative 286. And I'm going to get this long decimal, and I'm running out of room here for the next example, so I'm going to scoot over. So I have cosine of angle T is equal to 0.842 blah, blah, blah. So my third and final step to solve here, if my answer is an angle measure, I have to do inverse somewhere. So I'm going to do cosine inverse of 0.842 blah, blah, blah. So cosine inverse 0.842 blah, blah, blah. And my final answer is the measure of angle T is equal to 33 degrees. Okay, so let's go over that again. A little more work when you're after an angle measure. You start by simplifying the b squared plus c squared and getting it out of the way, and that's going to leave you with a negative number over on the left. You simplify the 2 times b times c, and you divide that out of the way, which is going to leave you with cosine of your angle is equal to some decimal, inverse cosine, and that will leave you your angle. So it looks like a lot, and it looks like a lot of work, but every problem is the exact same steps. Do this, inverse, and you're done. Okay? All right, y'all pause here and try C to go back and find an angle, side length again. Okay, so the important thing is to first mark which angle you have, so you can put your side length over on the left by itself. So this is what I get when I plug into the law of cosines. And this is one, if you're after a side length, you can just type it straight out and then take the square root, and you get x is equal to 6.5. And that seems like a reasonable answer because 21 is a very small angle, so he should have the very smallest side. Okay, last one, we are going to do a word problem. Here. All right, a sailing club has planned a triangular race course as shown in the diagram. How long is the leg along point BC? So we're looking for this. And how many degrees must competitors turn at point C? So we're looking for this degree right here. Okay, so before we can decide law of sines and law of cosines, we need to figure out what did they give us so I can figure out which one I need to do. So here we have side, angle, side. So if you have a side, angle, side, that is a law of cosines. So we're going to set that up. So they gave us the 45. So that means x squared is going to go over on the left. And it doesn't matter which one comes next. 3.1 squared plus 3.9 squared minus 2 times 3.1 times 3.9 times the cosine of 45. So this one's an easy one. We just type it straight away. So 3.1 squared plus 3.9 squared minus 2 times 3.1 times 3.9 times the cosine of 45. Okay, so that is 7.72 blah blah blah. Square root all of that, and you get that BC is equal to 2.78 when it's all nice and rounded. Now, I'm not all the way done with this problem, so I'm not for sure if I'm going to need to use BC again. So we know that for our final answer, we would round it to the nearest hundredth, but because I might need to use BC here in just a second to find angle C, I'm going to save this in my calculator. So how I'm going to do that is I'm going to hit the store button, which is right above the on button, and it's going to say answer. So it's going to take all the decimals and it is going to store it as X and then press enter. And that's why I tell you you're never allowed to use the X button on your home screen because your calculator thinks X is something. From now on until I tell it otherwise, my calculator thinks X is 2.77 blah 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 blah. Okay, so we're going to use that to our benefit in this problem. Okay, now when you look back at the problem, you can basically solve this any way you want to because I can do side, angle, side again, and I can do law of cosines to find angle C, Or I can do law of sines because I can have angle side side. So either way I want to work it, law of cosines or law of sines will work perfectly. So you need to think about what's easier for you. So if you're after an angle, law of cosines is probably not the way you want to go, because that's when you have to do that long and difficult solving method here. So if I can avoid that, I'm going to. So I'm going to use law of sines to try to find angle C. So I'm going to do sine of 45 equals, and that's where I'm going to put that 2.78. But I'm not going to use 2.78. I'm going to use my x in my calculator, and that's why I put those quotes there. Equals the sine of angle C over 3.9. So let's cross multiply. 3.9 times the sine of 45 is equal to 2.78 times the sine of C. Divide by 2.78. Okay, and I'm going to type this in right now. So 3.9 times the sine of 45. And I get this long number, and I'm going to divide that by x, because remember, my calculator thinks x is 2.7788 blah 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 blah. So enter. So what that means is the sine of C is equal to 0.992 blah blah blah. So if I want an angle measure, I'm going to do inverse. So I'm going to do sine inverse of 0.992 blah blah blah. Sine inverse of all of this. And the degree is 83 degrees. Okay, so this word problem was kind of a lot because you had to do both law of cosines and law of sines, so it had everything in it together. Okay, I know this is a lot. We're going to practice all class period tomorrow and then half the class period the day after that before we take the quiz. So we're going to get a lot of practice. But if you have no idea what I'm talking about here, then you're going to need to watch this again, okay? If you get it like 60%, then you're good. Okay, see you tomorrow.